Okay, hello friends, welcome to my lecture. Today I'm going to show you how to find sum of both arithmetic and geometric sequence. So here it is, sum of arithmetic progression. So as I told you in my previous lecture, arithmetic sequence or arithmetic progression is a type of sequence in which a difference between two consecutive terms, it is what? Constant. So this constant, what we call it? Common difference D. So here it is a formula for finding a sum of arithmetic progression. So it can be defined as Sn, or it's a sum of n term, which equals to a sum of arithmetic sequence as k starts from 1 up to n term n, equal with n over 2 times a1, that means a first term for an arithmetic sequence, plus n minus 1 times a common difference d. Okay, so this formula can be rewritten as like this. So Sn, which is a sum of n term, can be calculated as also n over 2 here times just a1. So we can write twice of a1, like a1 plus what? a1 is a1 plus a1 here, plus n minus 1 times d, n minus 1 times d here. Okay, so as I have told you in the previous lecture, n term for an arithmetic sequence can be defined as such like this. Yes, so this can be replaced by what? An, because this formula is, it is an n term for what? An arithmetic sequence. So a sum of an n term for an arithmetic sequence can be rewritten as what? N over 2 here times what? a1 plus what? The final, or the final term, that is what? An. It is n. So as you see this, we have two formulas for evaluating what? A sum of an arithmetic sequence. So if you have the first term and a common difference d, you can use what? This formula. And if you have a first term and a final term, you can just find, or you can just use this second formula. Yes, so for instance, if you are asked to find the first a sum of first 10 or 100 natural numbers, it's better to use what? This formula. Yes, so for instance, if you are asked to find a sum of the first 10 natural number, yes, so this can be calculated as what? The first 10 natural number means an can be what? 10. Yes, so is 10. For the first 10 natural number can be calculated as what? It's better to use this formula because we have what? The first term a1, and we have what? The final term what? a1, an, that means. So, and it is 10 here, so 10 over 2 times what? a1, that means the first natural number, it is what? 1 here. So plus, what is, it is 10 here. Yes, so this can be calculated as what? 10 over 2, that means 5. 5 times 11, that is what? 55 here. So instead of adding 1 plus 2 plus 3 plus 4 and so on, it's better to use what? This formula. Yes. So to find a sum of arithmetic sequence, just you can use what? Two basic formulas. Just you can use this formula if you have the first term a1 and if you have a division d, or you can use what? This formula if you have the first term a1 and what? The final term what? a1, an. So let's do exercise on this type of sequence. Here it is. Given the arithmetic sequence 3, 7, 11, and 50. So the question is find a sum of what? The first 10 term, and find the sum of what? The first 20 term for this given arithmetic sequence. So we have a formula just to find a sum of arithmetic sequence. First we have to calculate what? The deviation d, that means a common difference for this arithmetic sequence. So this D can be calculated as what? Just by subtracting the second term, the first term from what? The second term is A2 minus what? A1. Yes. So here it is what? The second term for this arithmetic sequence is 7. So 7 here minus what? Minus 3. So here it is what? 4. So a common difference for this arithmetic sequence is calculated as what? 4. So now we can calculate what? A sum of for any n term. Yes. So if we are going to find the sum of first 10 term for this arithmetic sequence, we can use a formula. Yes. So it's 10 which equal with n over 2. That means 10 over 2 here over 2. Yes. Times 2 times a1, that means a1 it is given as 3, so 2 times 3 that is 6 here, plus n minus 1, that means n minus 1 means 10 minus 1, that is what? 9 here. 9 times what? D, a common difference for this arithmetic sequences is calculated as 4, so now if we simplify this as 10 over 2, that is what? 5 here, 5 here times 9 times 4, it is 36. 36 plus 6 is around what? 42. Okay? 42. So this can be simplified as what? 210. Yes? So if you find a sum of these first 10 natural numbers just by using calculator, you can also obtain what? 210. But instead of adding 3 plus 7 plus 11 plus 50 and so on, it's better to use what? A formula for just finding a sum of arithmetic sequence. So next, and find a sum of what? The first 20 terms. That means it is symbolized as S20. So this can be calculated as 20 over 2, that is what? 10 here. Yes, 10 times a first 2 times a1, that means a first term for this arithmetic sequence, that is 3. So we can have 6 here, plus, so n minus 1, that is what? 19. Yes, 19 times 4. 4 here. Yes, 4. We have 4 here. So this can be further simplified as 10 times, so here it is 19 times 4, that is around what? 76, yes? So 6 plus 76, 76 here. So 6 plus 76, that is 82. So 82 times 10, that's what? 820. Okay, so if you add a sum of for this 20 term for a given arithmetic sequence, you will obtain what? 820. So this is all about how to sum or how to find a sum of a given arithmetic sequence. So here it is. Second type of sequence, which is geometric sequence. So as arithmetic sequence, a geometric sequence, it is a type of sequence in which the common ratio for a geometric sequence must be what? A non-zero constant. Yes, so a general formula just for finding a sum of geometric sequence, it is like here. So there are two formulas for finding sum of geometric sequence. The first one is Sn can be defined as n times g1. Yes, if and only if what? R is equals to 1. Yes, for some cases a common ratio may be 1 if and only if what? All elements or all terms of a geometric sequence is what? Equal. So for instance, if we have like 5, yes, 5 here, 5 for G2 and 5 for G3. Yes, 5 for G3 and continue. So this can be termed as one. Okay, so if we have a sequence like this, so for this sequence, a common ratio R can be calculated as just by dividing the second term to the first term, or just by dividing the third term to the second term. So if we divide the second term to the first term, we obtain R equal with what? 1. So we can obtain a common ratio R which equal with 1 if and only if what of all elements of a given geometric sequence must be what? The same, yes? So if you are going to find a sum of the first 3, yes? If we have 3, if you are asked to find a sum of these 3 geometric sequence, so you can use this formula, yes? So just S3 can be calculated as what? Yes, n times 2, that means 5. So you can have 3 times what? 3 times 5, yes, that is 15, yes, so 15, 1, 5. So you can check also just by adding this listed sequence, 5 plus 5, that is 10, plus 5, that is 15, yes. So it's better to use what? This simple formula is finding a sum of a geometric sequence if and only if what? A common ratio for any geometric sequence must be what? 1, yes. And the second formula for finding a sum of geometric sequences like this, so this can be calculated as G1, that means a first term for any geometric sequence times 1 minus R. R means it's a common ratio for a given geometric sequence, the power of 1 over what? 1 minus R. So this formula is used for finding a sum of geometric sequence if and only if what? A common ratio is what? Different from 1. So let's do example for this type of sequence. So here it is 1, 2, 4, 8. Yes, first let's check whether this sequence is geometric or not. Okay, so if you divide the second terms to the first term, you obtain what? 2. Okay, and also if you divide the third term to the second term, you also obtain what? 2 here. So we can say that this sequence is geometric. So we can find what? A sum of the first 5 terms. Here it is. So we have a formula for finding a sum of any geometric sequence for a common ratio different from 1. So its then can be calculated as G1. That means G1 here. Yes, G1 times 1 minus r to the power of n here. 1 minus r to the power of n. Okay, over what? 1 minus r. So here it is. We are asked just to find a sum of the first 5 terms for this arithmetic sequence. So we substitute n value by what? 5. Yes, so G1 it is given as 1 here. 1 times 1 minus, yes, r it is already calculated as, or we can find r as what? G2. That means the second term for this geometric sequence, G2 over what? G1, yes. So G1 here. So G2 is given as 2 and G1 is given as 1. So 2 over 1, that is what? 2. Okay. So 2 here. So now let's substitute the value of a common ratio on R. So to the power of what? To the power of 5, since we are finding what? A sum of what? The first 5th term. So we substitute n value by what? 5. So 1 minus what? 2 here. Okay, this can be further simplified as 1 times a number is that number, so 1 minus to the power 5. That is what? 32, yes? 32 over what? Minus 1 here, yes? So this can be further simplified also. Minus, yes, minus 33. No, minus 30, actually not minus 30, it's minus 31, yes? Minus 31 over minus 1, yes? So we can just cancel this negative by this one. So S5 for this geometric sequence can be calculated as what? Calculated as 31. Okay, 31 here. Okay, so you can cross-check just by adding these listed terms, yes? 1 for the first term, 2 for the second term, and for the third term, and 8 for the third term. And what is the fixed term? It is what? 960, yes? 60. That means 16. So if you add 8, if you add 1 plus 2, that's 3. 3 plus 4, that's 7. 7 plus 8, that is 15. 50 plus 16, that is 31, yes? So instead of adding 1 plus 2 plus 4 plus 8 and so on, it's better to use what? A formula for finding any sum for what? Any geometric sequence. So this is the end of my today's lecture. So please try to like, share and subscribe this channel for more videos.